is working. Okay. Hi, good morning. My name is Carlos Morato. I work in Optum. As probably I found this in a lot of venues that Optum is not actually very well known. So I'm going to clarify a little bit who we are. So Optum actually is the technological brand of United Health Group. So what we basically focus in creating technology, and in some cases, in particular my team, and that's another organization within Optum, that's Optum Labs, AI solutions that support or actually enable the progress of some of the services that we have in healthcare. So in terms, to understand the impact of AI in healthcare, first we have to try to understand how the healthcare ecosystem works, right? In this process, I don't know if I can move. Can I move? Okay, it seems like not. So in this ecosystem, we can see that there are three different types of services. Now, one that's associated to the inpatient. Oh, thanks so much. Hello, okay, that's better. Okay. Now, one that is associated to the inpatient, right? That's one of these vertices of this triangle. The other is the healthcare provider, hospital, clinics. And the third part is the insurance. In a perfect world, these three will be completely integrated, and we will be trusting as a patients, we will be trusting 100% in our provider and trusting 100% our insurance. And wherever that you are sitting, if you are in the healthcare, you will trust in the other two, right? So these three vertices can be actually divided in three different kind of services, if you want. One is the healthcare delivery that we were just mentioning, that's associated to the, to the provider. Challenges applications in that area are the prioritization for pharmacy. Another could be prioritization for special care. When we decide to, or when the provider decide that we need an extra service, seeing this, the special service, and post-acute care recommendations. For example, if we need long-term care, or if it's needed, for example, special services associated to, skilled nursing or nursing homes, and so on. The part of the population, that's basically us, right, is how can we measure the evolution of this population? And how that's important is because based on how we measure, for example, the health of the population, we can actually assess a risk for the specific populations. Assessing risk is very important because that will define the cost of the services. Blindly assessment, like probably used to happen probably 40 years ago or so, when we didn't have access to this amount of data, obviously tend to be biased. And obviously we want to be accurate in this time, in this age, and also because we have the data, and also we know that there are different behaviors in different kind of populations. Also, the introduction of how we measure other kind of metrics. In this case, for example, the healthcare efficiency, data information set, how we measure that metrics. Or finally, we can also, how we basically work with prevention on recommendation of services. In this area, we will find the proliferation of virtual services. Something that pre-COVID were highly regulated, and starting COVID, the regulation, at least in the United States, was open and brought a new type of services. Services that, for us that we work in this area, obviously, they were very, very mature in Europe, because we're talking about a maturity almost 20 years of these kind of services. Now we can see these differences in and different perspectives. Here it's not right or wrong. I think it's an issue of what's the perspective that we have. Now, if we have a pre-screening using a telemedicine service, we probably are, if we're screening and we are downsampling too much, we probably are privating the service to someone that really needs. But obviously, it's impacting the cost because the pre-screening is actually much cheaper than going to the doctor. Now, that's basically probably the position of any kind of healthcare provider or healthcare insurance in the United States. But if you ask this in, I don't know, Switzerland or in Germany, you will see that actually this saves tons of money, right? Because we can actually avoid the people go for just a flu to the doctor when basically you are going to be having, I don't know, your prescription will be Tylenol, and that's it. Now, so there's all the time this gray area in terms of what's the right perspective or what's the right approach to go. Finally, healthcare operations. So it's auto-adjudication. That's basically if we decide to pay or not, right? And that's the big challenge in healthcare industry. Chart operations, network designs. How do we know what's the best networking for you, right? Now, for many now, we can actually see a lot of similar behavior as recommendation systems, right? As when we can actually have some kind of personalization. So that's a possibility there. Medical coding. The way that now we centralize a lot of the services associated to a specific type of care, or illnesses, because we have different kind of descriptions, different kind of ways that we describe these services. The way that we do is we use codes. We do some standardization of these codes. But turns out right now, this process has been done by people, right? So actually, people go to have a certification in medical coding. Because they have to know how basically are going to put a code that is probably an ICD-10 or a SNOMED code that describe the type of, for example, medication or the type of pathology that we're seeing in the documents. So there's a possibilities there, right? So it means it's a manual process, prone to a lot of errors, right? That eventually need to be reviewed. And obviously, provider directory accuracy. How many times you find out that, I don't know, when you are in your records, no matter what's the provider, what's your healthcare insurance, you will find out that actually you don't have a very accurate description of doctors, right? So sometimes the one that's going to be recommended is going to be someone that actually lives in Oregon, right? And obviously it doesn't make sense at all, right? So that's some of these opportunities in AI. So how we decide that's the most important thing to go in? What's the most important, I don't know, I would say parameters that we will take in order to implement or decide or to tackle a problem in this domain. Number one, business value. So we hear all the time that, well, the healthcare business is $2.7 trillion business that obviously the only thing that's happening is going to keep growing and keep growing. So where's the value though? So where we should be investing? Obviously, new services is the first thing that come up. That's the reason that we have this proliferation now of virtual services, that we can actually innovate in that area. But another variable that's very important is the amount of data that we have. The healthcare data of the whole ecosystem is very fragmented. Because before before 2011, 2012, before basically the Affordable Care Act, there was not a mandate, that basically, push the providers, to share their data. So you probably remember, well, many of you are very, very young, right? That if you change the provider, you need to go with your yellow folder, or you need to go and ask for your yellow folder, and have a copy, or tell the doctor or your provider to move that folder, fax that information to the new provider, right? Obviously, data is an issue. Accuracy in the data is an issue, right? Well-labeled data. Do we have ground truth? No. Do we have baselines to actually challenge or to try to tackle these problems? And baselines is very important if we want to generate or develop machine learning models that are actually accurate. And obviously the four parameter, and it's very important parameter, is the regulatory environment, right? So can you use the data? No. It's a PHI data. No. And that's one of the issues that we have. And that's the parameters that we should take into consideration. So one example of this implementation, one of the projects that we actually deploy, one of these products that we deploy is our written medical charts. Medical charts is basically a lot of documents, text that normally comes into fax, or we finally have digital inputs of that. So basically it's text, plain text. So therefore we can apply techniques of NLP that allow us to basically review these medical charts, verify based on the context and the contextual information that we have, if these medical charts contain enough evidence to probably suggest that that patient needs and needs to see a special doctor or needs a special care. So that's basically one of the ideas that we have, or one project that actually we deploy. Why was it important? Because right now this process, or before this model, this process was actually done manually, right? So we have a traffic of almost 200,000 records, right, per day that need to be screened, needs to be verified. So and after that, we have to, and the reason that they have to be verified has to be verified to provide the service and also to pay for the service. So basically, we decide that that's a good way to go. As you can see, probably not too much excitement in the type of techniques that we do. NLP, very robust technique. The key is how we implement it. In healthcare, we cannot assume that, and it's for regulation, that a model will actually be part of an end-to-end service. So this means the model cannot tell you that you will have or not a service. So this means the model just have to suggest to the specialty, to the doctor, and after that decide if it's okay or not. But basically by doing this, we reduce, first of all, we reduce our error rate, and also we increase the amount of records that we process. But it came up with another, well, obviously we work with our metrics. The metrics allows to understand that turns out, well, there's a lot of records, even with our models that we didn't actually cover. And there were some issues associated to this, to these records, but still we improve the accuracy of the process in general. Now, something that I want to tackle here, and is that one of the issues that we have is also for regulations is that your models cannot be black box, right? But most of the models that we have in machine learning are black box. So how can we add interpretability? How can to our models? So it turns out, obviously, things that makes these models fantastic is something that also is against regulations, current regulations. Now, what makes our models fantastic is that we can embed everything in numerical vectors that are canonical representations and that are fantastic for processing. The problem, obviously, we cannot find the meaning, right? So we can have a vector that's 765 numbers, but we don't know what actually this number means, right? Automatically. So we have to figure out how we develop techniques that allow us to process or to generate some visualizations, because that's the only moment in that this algorithm will be able to be clear by regulators and be deployed. So what we developed basically was additional algorithms for visualization. So that highlights words that actually are embedding some of the the key aspects of, for example, in terms of importance, in terms of frequency, or that embedding some rationale that's associated to the document of, in this case, a medical chart. That allows first of all, to provide some insights of what actually the algorithm is doing. Another visualization that we had was basically adding clinical NERs. Now that allows us to understand, for example, a lot of the modifiers, disease detection, and also the detection of codes. This means that now we also can see the codes as the coder introduced, and how we can actually evaluate and automatically detect the codes in the medical charts or in electronic records. All these tools allows this, probably I will say, traditional machine learning model to actually now be a product that use human in the loop to make accurate decisions. In addition, we add tools that allow us to understand the doctors, how they basically have to develop some trade-offs, how to modify these trade-offs, and in that case, now they can also decide how they will be modifying these trade-offs in order to proceed and use these tools. Because again, these tools are not for the healthcare insurance, it's more for the provider. Finally, our deployment. And here's another challenge that I want to put in this way. Now, if we see this process, that's a very traditional process, right? So in deployment, except one, the retrain of the models. In a traditional organic system, right, we have access to the impact of the metrics. That means the impact of the algorithm right away, right? If we're talking about, for example, a search engine, so once that you have a query, you have the output, and you click, right? It's an organic access to the output, to the feedback from the user. One of the key challenges to improve machine learning models in healthcare is how to deal with outer loop metrics. How we deal with metrics that actually are fragmented. Why? Because the systems are fragmented, right? So once that we produce something, like once that we have, for example, once that we have a model that is impacting the time of service, the question is, when are we going to have the feedback that actually how our model impacted that service? That can take months. So in that period, our models maybe are impacting maybe negatively or positively. The problem is that it's not clear. We are not tracking, and there's no way currently to track some of these algorithms. That's a limitation, and it's a limitation of integration. And it's something that you will be hearing more and more in the healthcare domain, because once that we manage to have integration, we probably will be managing also to have a more, an explosion of different kind of algorithms and how to deal with these challenges between the traditional inner loop metrics that are associated to our traditional models versus outer loop metrics that are more tracking the behavior of our models, or how our models are impacting the world. And I think my time is done. Well, I have one more, but I don't know if you guys